Hello and welcome to a Tech Byte video about QAQC for CCS models. Today, we'll be discussing the QAQC of the reservoir properties as well as the component section of a CCS models. Later, we'll talk about a clarification in terms of the capillary pressure values in a saline aquifer model. Finally, we'll have a discussion about the numerical section. Without further ado, let's start. First, let's discuss the QAQC of the reservoir properties. In a simulation model, it is highly important to have a relationship between the porosity and the permeability. If you would like to analyze this type of distribution, this type of relationship, you can do it in Builder. In Builder, go to Reservoir tab and click on Analyze Properties. Once you click on Analyze Properties, a window like this will be shown. Here, you can specify which are the properties for which you want to analyze the relationship. In my case, I'm visualizing the permeability in the I direction and the porosity. As you can observe, there is no clear relationship between these two properties, which can lead to significant convergence issues. You may have blocks with very high values of porosity but very low values of permeability. As mentioned, that will lead to convergence issues that will have a negative impact in the performance of your simulation. When there is a lack of relationship between these two properties, it might be worth it to contact the petrophysicist or geomodeler, as usually this is related to mistakes in the workflows when modeling the permeability. Nevertheless, in order to diminish this negative impact in the convergence in the simulator, you can use the min-val and max-val keywords. These keywords allow you to set a minimum and maximum value respectively for any property in your model. So let's say you want to specify a minimum value of permeability in your model. You want the minimum value of permeability to be 0.01 millidarcy, for example. You can use the min-val keyword to do that. To specify the keyword, you can do it in cedit or any text editor. So if we go to cedit, we look for the property for which you want to specify this minimum value, in this case perm I, and then just specify the keyword min-val 0.01 millidarcies. In this case, if there is any block with a permeability value less than 0.01 millidarcies, the simulator will set the permeability as 0.01. This to prevent the convergence issues. Another important aspect to analyze is the pore volume of the blocks. Sometimes we can have blocks with very low pore volume that can impact in a negative way the convergence of your simulation. To prevent this, you can use a cutoff of the pore volume. For this, we have a keyword specified as PV, cutoff, and then the value. So if there's any block, in this case, with a pore volume less than 1,000 cubic feet, the simulator will consider them as null blocks. With this keyword, you're ensuring that blocks with very small pore volume can be removed from the fluid flow simulation, and therefore prevent the convergence issues. Also, in terms of the thickness of the blocks, it is important that you don't have blocks with very low thickness values that can also impact in a negative way the convergence of your simulation. Sometimes you can have blocks of even 0.01 foot, but at the end, that would hinder the convergence of the simulation. To prevent that, you can pinch out those type of blocks. In that way, you're allowing the vertical flow but not the horizontal flow. So in order to specify the pinch out keyword, we set pinch out, tall, and the value. For example, in this case, 1 foot. So if there is any block with a thickness less than 1 foot, the simulator will consider them as pinch out blocks to prevent the convergence issues. So far we have discussed the QAQC in terms of the reservoir properties. Now let's discuss the QAQC in terms of the component section of your model. So in the component section in your model, it is important to check, for example, the solubility input that you have. Check the inputs for Henry constant. Make sure that they are reasonable. Also, it is important to mention that when you have a saline aquifer model, the methane should be specified as a tertiary component. This to prevent convergence issues. You can use the tracecom keyword. The tracecom keyword allows you to specify the component that is going to be considered as tracer, that will prevent the fluid phase from completely disappearing in the water zone when gas solubility is activated, for example. So for CCS models in a saline aquifer, it's very common to have the trace component as a methane. Also, it is very important that you are aware that there is a phase ID keyword that specifies the method to identify the phase in a block. So by default, it is based on the density. However, you should check the conditions of your reservoir in terms of the temperature and pressure to see if you're very close, very near to the critical point of the CO2. If you are very close to the critical point, we suggest analyzing the use of other methods in this phase ID keyword, such as TC-mix, that considers the temperature of the block. Also, we suggest setting a SWOC value of 0.9999. Do not set it as 1. which will lead to convergence issues. Now, let's discuss the capillary pressure values in a water gas system. When you have a CO2 injection in a saline aquifer and you have capillary pressure values between the gas and the water, they should be specified in the SWT table. Do not set them in both SWT and SLT tables. If you do that, you will be applying the capillary pressure values twice. You will be doubling the effect, which is incorrect. So again, the capillary pressure values should be in the SWT table. Now, in terms of the numerical section of your model, we recommend using the keyword ADTSC on. Often, it provides improvement in the simulation time. The plots that I'm showing here are for CCS models. So you can see there was an 83% reduction with only adding this ADTSC on keyword in the numerical part. And in this case was 67. So again, usually this is very useful in terms of reducing the time of the simulation. With this, I finalize this Tech Byte video. Thank you so much for watching it. If you have any question, any issue, please contact us at support@cmgl.ca. We'll be very happy to help you. Thank you, and I hope I see you in the next Tech Byte video.